All right. I suppose we're going to continue our discussion of 6741. Kindly asking if you could please confirm if you can hear me. I know you can see my screen because I've just I believe I've just shared it. Can you hear me just fine?
I can hear you, but it seems I'm the only one.
Yeah, that's fine. We can proceed, right? It's not uncommon to have a class with just one person, so yeah, it's fine. We can proceed. So it turns out, right? If you remember when we met last time, I believe we had started going through well, lecture series number 2, really, but we were discussing reproducibility. So we had an interesting conversation where I believe we had gotten to a stage where we looked at Jupyter notebooks, okay, and we actually parted ways when I was essentially hinting at the fact that Google Colab is essentially a cloud-based version of Jupyter notebooks, right? Um, so I'm not sure if you had a chance to look at the I want to say the I mean, if you had a chance to install, Jupyter Lab or Jupyter Notebooks, classic Jupyter Notebooks, and also if you had a chance to poke around Google Colab, right? Or is there any specific questions related to what we had started doing? And there we go. There's a notebook I was using right here. Okay, so if there are no questions, right, I just wanted to kind of highlight some interesting features, related to Google Colab or Google Collaboratory. You know, um, the fact that um, obviously the first thing that you probably want to appreciate is the fact that Google Colab is essentially a no-install software. So it's similar to Gmail, Google Docs, or Google Sheets, if you will, right? So it's made available as a software as a service application idea, and all you need really is a browser. In terms of the functionality, what you begin to notice is that the interface actually mimics um, Jupyter Notebook and Jupyter Lab, right? So you notice you have the toolbar here, which gives you access to to features that will enable you to, run, excuse me, to run um, the the cells, right, associated with the notebook itself. Typically, as opposed to, is it Jupyter Lab or Jupyter Notebooks, which will have a feature in the toolbar that allows you to execute a single cell. In the case of Google Colab, you actually have the play button, which is on the leftmost side of each cell that you create, right? So in this particular case, for instance, if I wanted to create a code cell that just prints, 2026 plus 2, for me to execute this cell, I'd have to first of all contextualize it, and then I just click on the play button. And because this is a code cell, the output is going to appear right at the bottom, which is pretty straightforward, right? In addition to this, though, what you begin to notice is that if you look at the panel that is on the leftmost side of your screen here, you have access to these two tools here, right? I want to call them tools here. So on the top here is a table of contents button that essentially allows you to view the structure of your notebook. And it turns out that this structure is best perceived from the way that we said you can potentially structure your notebook, right? So in other words, you only be able to see things that fall or that are aligned with the different structural elements here in terms of header. So for instance, if let's say I wanted this very first section here to be the one heading that speaks to Jupyter notebooks. I would do something like Jupyter notebook, right? And then maybe afterwards here, I would want to have a subsection to level 3 heading that speaks to Jupyter Lab. It's a Jupyter Lab that says Jupyter notebook or something. You notice as I am creating the different levels, so Jupyter notebooks here is level 2, this is level 3, right? The structure is implicitly being constructed on my behalf. If I then want to include a subsection level 3 heading that is tied to Google Colab, you notice that a structure will be created on my behalf here. So this table of contents essentially mimics what we typically do when we are working with word processors, right? So tools like Microsoft Word, for instance, where you can generate a table of contents essentially. And this makes sense really, right? Because we know that if you're working on a large-scale data mining project, one of the things that will happen is this notebook is going to grow in size, right? So it will span multiple pages. And one of the easiest ways of navigating to a desired location is by using your table of contents. There's a feature here, a button that enables you to find and replace text. Again, quite useful in instances where you want to replace text globally. It has happened in my case, like let's say you want to replace like the name of the function or something, and your function is being used in multiple sections of your notebook. You can do a find and replace. You know, you have access to quote unquote code snippets. These are more or less like code blocks that act as a scaffold, a starting point in essence. So some of these we may not necessarily use, but you notice that there are code fragments that are associated with some of the libraries we're going to be using. Like for instance, matplotlib, right? I think there should be something to do with matplotlib, probably not yet. Visualizations, right? So you can plot, you can create a scatter plot, for instance, a histogram and all those things. So, you know, contextualize a cell here and then choose one of these scaffolds, right? Insert, right? So once I insert, I have a starting point, really. I don't have to start from scratch. Tremendously helpful, I suppose, is snippets. Already kind of like organized in a very useful manner, right? So all you do is you literally would be replacing these, replacing specific portions of the code base. Like for instance, you replace the dataset that is being used by your own dataset, but then the visualization would essentially be the same as what you're seeing in the code fragments here. So quite useful there. The other feature that is there is, if you notice here, there's a data inspector, usually very useful when you integrate data sets within your notebook itself. So you're able to kind of like visualize the data, right? So if you notice here, I just clicked on this and then I have access to, you know, different rows associated with my data set. I have a sense of how many records, you know, I have. This is 406 observations or records ideally. And then these would be like your columns ideally with their corresponding data types. Again, just allows you to inspect the data. You'll be able to appreciate this when you look at Python Pandas functions such as you know, pd or dataframe.columns, for instance, or dataframe.head, right? It turns out like having access to this sort of like visual data inspector makes life relatively easier, ideally. Okay. There are instances where you will find yourself interacting with web services or application programming interfaces. So integrating them right within your code fragments in your notebook. What you can do is you can define the API keys ideally, right? So this notion that for some APIs, you only be able to interact with the APIs if you have a key, right? So you can define the keys right within here. Probably one of those features that you use often is files button here, right? And it turns out that what it does is it makes it possible for you to integrate data sets within your notebook. And really, if you look at a typical data mining or data science project, one of the key ingredients is the data that you're going to be working with. Okay? Interestingly enough, there are two fundamental ways, I want to say three really, but within Google Colab, the two main ways that you can leverage to integrate data is you can upload the data. So you notice when I contextualize this here, there's an upload button here, right? The content pane here, the side panel. And what this does is it allows you to navigate, right, within your machine, your local machine, and choose a file, a data set that you'd want to upload. I have a sample data set, I believe, in my downloads folder, and I'll showcase this as an example. So what I'll do is, if I'm constructing this notebook in such a way that I would want to use that data set, I'd come here and I would upload this data set. So I'll navigate to the directory that has that data set on my computer. In this case, it's my downloads folder, and this is the file, and then I would upload it, right? Now, interestingly enough, what pops up every time you upload a file, within a session is you're given a warning, right? A warning that signals the fact that what you're uploading is going to be considered as a runtime file. A runtime file is essentially a file that is tied to your session. So every time you log into Google Colab and you create a notebook or you open a notebook, there's a session that is created, okay? In other words, actually, implicitly what is happening is there's a virtual machine that is spun, right, or created, and you're given access to that virtual machine. Now, it turns out that once your session expires, like let's say you close your browser, for instance, or shut down your machine, when you go to Google Colab, you're essentially going to open a new session. And once you do that, this file that you would have uploaded in here is going to vanish, in essence. It will disappear, right? It will no longer be there, right? So it's something that you need to probably take into account here. Again, I think I had mentioned or showcased when we were looking at cell magics that this is Google Colab, right? I'm in Google Colab right now, and I can check the operating system, right? The operating system that is associated with the virtual machine I'm using in Google Colab implicitly. Okay? And what I can do is I can do the same thing I run on my local machine. This is my local machine here. If I just run the command lsb release -a, this what this command tells me, Ubuntu tells me that I'm running Ubuntu version 24.04.4, right? With long-term support, LTS. If I run the same command, yeah, in Google Colab, I'm on Google Colab right now. Remember, this is an OS level command, so I have to use the OS magic, which is exclamation mark, and then I'll run lsb _release, right? If I run this, what -a here, what Google Colab is going to tell me is that, listen, you are using Google Colab, and the Google Colab that you're using is actually installed on a machine running Ubuntu version 22.04.5. Again, long-term support here. This is jamming. Whereas on my local machine, I'm using Noble, right? Slightly, one major version, one notch above, I think. Is it one or so? No, 2. So there's 23, and then I'm on 24 here. Although 23 is not an LTS version, is it? But so there's this, right? The key thing here is it's relatively easier for you to interact with these data sets. Like for instance, once I upload this data set, and we'll get to a stage where we do this, I can install Pandas, although it's already installed. I can install Pandas. Once I install Pandas, I can then access this file here because it's part of my session now. I'm just going to copy the name here, which is just going to say the name and copy it. And what I can do is I can do a pandas.read CSV, and then I'll say I want to read the data itself. And true to that, this is a .csv. And true to that, when I run this, I have to import, by the way. Once I do this, I've got to have the code cell here, which will enable me to import. So I'll say import pandas. And when I run pandas.read, it's going to render the output of the file itself. And the file incidentally uses a pipe symbol as a separator, so I have got to explicitly do it. It doesn't use a default comma, right? It's delimited using pipe symbols. And so when I run this, it's going to render a data frame that incidentally corresponds to the data that is in this file itself. Right? But what is key here is that I'm using this feature here. If I click on the files button, I'm using a feature that allows me to upload files and tie them to my local session. But it turns out that there are instances where you'd want the data that is integrated or referred to in your notebook to persist, is it? You want it to be always available. Every time your notebook is being run, it's available. Well, it turns out that what you can do is you can link Google Colab to Google Drive. Okay, so you notice here there's this button. If I click on files in this left panel here, left menu bar here, second last one is files. I click on files, I can upload, which I've showcased. If you are adding a lot of files here, there's a feature that allows you to refresh, right? So that you see an updated list of files that you're working with. Interestingly enough, right after this refresh button is a button that allows you to mount Drive. In essence, what this does is it enables you to link Google Colab with Google Drive. Okay, so observe, I just click on Mount Drive. Life has become somewhat easier. And I'm going to go through a process where I need to explicitly grant permission for Google Colab to be integrated with Drive. Okay, so I just click the Connect to Drive button here in this pop-up window. And once that happens, I'm going to scroll down here. Where is that? Once that happens, I'm surprised that this hasn't popped up here. Once that happens, you notice here that there's a new folder that just popped up here called Drive, is it? And if I expand this, it turns out that I have access to a number of subdirectories. So you can view this Drive as a directory, and then there are subdirectories here. So there are these two hidden files here, trash, 0, and shortcut targets by ID. But I want to draw attention to, I'll just click on hide hidden files here because I don't want they'll be confusing here. I want to draw attention to my Drive and shared Drive, right? It turns out that what you have access to here mimics the things that you do when you're in Drive. So I'm going to, alongside this, I'm going to navigate to my Google Drive, right? Installation. Observe. In my Drive, this is what I have access to, yeah? I'm just going to refresh here. This is my interface in Google Drive. And you notice that for me to access files, the two places that enable me, or that facilitate access to these files are my Drive, right? And my shared drives. Incidentally, you only get to see shared drives if you're using Google Workspace or something, paid for version and all those things. But observe, I can expand my Drive here, right? My Drive has a number of subdirectories. If you notice here, there's things like Google Colab, Classroom, Google AI Studio, reports, research, and incidentally, I organize my work in such a way that everything I teach is in a subdirectory under my Drive called teaching. And under teaching, I'll have the different years when I've been teaching. Currently, I'm teaching 2026. If I expand this, I have all of these courses that I'm teaching here. Now, if I go to my Google Colab and I start expanding my Drive, what you notice is that the structure is actually going to mirror what you're seeing here. There are some subtle differences, like for instance, my Drive here has a space, is it? It's my space Drive. But once this is mounted, the space is removed. The same applies to shared Drive. Now that's neither here nor there. You have no control over this. But if I expand my Drive, I have access to these subdirectories under my Drive that are exactly the same as what I'm seeing in the Google interface, right? Observe these things. Somewhere at the bottom is teaching. If I expand teaching, I have all these years. if I expand 2026, I have access to all the courses I'm teaching, including the course associated with your program, is it? What I'm teaching right now, which is programming for data science. Yeah. Again, if I expand in here, you notice that the directories associated with this are actually the same here. If I come in here and I go to 6741, I'll find that there's a slides directory, right? Now, the point I'm trying to put across here is that if I want, because once I kill this session here, I will no longer have access to that file that I had uploaded. It will vanish. And I think we can mimic this kind of, I guess. I'm just going to disconnect here and delete the runtime. Boom, right? If you notice here, it's telling me, are you sure I want to reset this runtime? The state of this runtime, including all local variables and files, will be lost. And if I say yes here, right? And I kind of like refresh this so that I start on a clean slate, okay? The notebook, by the way, is being saved, right? But now, if I go and run this code here, right, where I have Python pandas, I'll start from here, and I import. So I'll install, and then I'll import, and then I'll try and read, right? I know it's taking a while here to kind of execute because I've essentially restarted my runtime. Yeah. Once this is done, and I run the import pandas cell, it's imported. If I attempt to run this, right, I get an error, is it? And this is a file not found error. I'm being told that this file does not exist. And the reason it doesn't exist is because the reason it doesn't exist is because the runtime is dead, right? The file is not there. So for that to work, I would have to come back here and I click upload and I go back here, right? And I again re-upload the file, right? So I'd have to re-upload this file here. Only then will this work, right? Again, I'll get the same error, right? To tell me to say, you're uploading this, but be wary of the fact that when your runtime is terminated or it dies, you will not have access to these files, which can be quite cumbersome, right? Now that I've uploaded it and I run this, that error won't be there. The file not found error will not be there, right? To work. So a workaround for this is you essentially can have these files in your drive, in your Google Drive. So what I'm going to do here is I'm just going to create a folder here called Datasets, right? In my drive. And then in here, I will come to, and I'm going to just have to rewrite this so that it's, I'm just going to call this Datasets or something. And then I'll call this 741 here. So I use the file associated with you. Some dataset that I use really for these other courses I teach. So from here, what I can do is I can say, you know what I want to do now? I want this data to persist. And what I'm going to do is I'm going to upload this dataset here to my drive, is it? Dump it in here. It's going to be uploaded. And because I've uploaded it to my Google Drive, my drive here, I can come here and I can mount drive. Okay? I go through the same process. I mount drive, and incidentally, when your runtime terminates, the next time you try to access it, you'll be requested to mount drive again, which is fine, right? Mounting, remounting is fine because you know that the data that is in your drive persists, it's persistent. Okay? So again, I will navigate to my drive. And incidentally, I'm navigating here because it's one of the easiest ways of avoiding errors, right? What I could have done here is I can use cell magics here and just say, I want to see, right, which directory am I in? It's determine content, okay? If I'm in content, I want you to list the directories that are in content, okay? So I have this file that I've just uploaded, my session, and then I have the folder called drive, okay? If I have the folder called drive, I want to check, right? what exactly is in content? Drive. Right? This thing is going to tell me, oh, you have my drive and shared drive. Okay. What about in my drive? Right? So it's like I'm recursively trying to see what is there, what is there, what is there. And you notice here that I'll eventually get to a stage where I'll see all these subdirectories. I'll see teaching, which has all the years. And then I want to access this here, 2026, like so. Right? I see all the subdirectories, and then I know that the directory that is associated with what we are doing in this course is miscellaneous MISC hyphen, and then I have UNZA 26. You know, after UNZA 26, I have this. I have this is UNZA MDS hyphen CSC 6741. I should change it so that there's consistency. And then in here, I'll have the datasets and slides directory, and then I can have datasets here. And then from here, I'll be able to see, right? So it's like the absolute path when you're using, in essence, when you're using, what do you call this? When you're using Drive, when you're accessing files in Drive, you've got to use the absolute path, is it? So this would be the thing that you are using here, the entire path, absolute path, relative path. Now, to avoid this, right? I mean, if you know how to do this, and if you understand the structure of where you're storing data, it's quite trivial for you to know, right? The location. Like I know the location. I can easily find the location here. It's not a problem. But if you don't and you're just getting started, what you can do is you can use, right, this file browser here. So you navigate to my drive, you scroll down and say, oh, the thing I'm looking for is under teaching. And then I'm going to scroll down to 2026, scroll down to the course itself. In this case, it's this one, CSC 6741. And then I'm in datasets, right? I'll expand datasets. Now it turns out that when you expand datasets, it will list all the files in that dataset. And one of the files is the one that I've just uploaded. You see, if you hover over it, there'll be this menu item. This is a kebab menu item or something like that, right? These three vertical dots here. You click on the three vertical dots and then you choose the option that says copy path, right? So you click on copy path, and what you are copying is the absolute path to the file itself. So if I paste this here, you see this? Same exact thing that I had gained access to here. Now, this is what you would be using to then access your data. So you can do your pd.read CSV, and then you specify it. So the file I want is specifying the absolute path linking to the file. And then we'll discuss pandas later on here. Separator is a pipe symbol. And if I run this, it's going to work again. Same as before, right? It will work. Now, the beauty of doing this is, it's taking a while to run here, it's still executing. The beauty of doing this, I have to import again, Python. Okay, I don't have PD, I didn't use the alias here. So I have to write pandas, like that. The beauty of doing this is that if I again kill the session, which I'm going to do right now, I'll go to runtime and I'll say disconnect and delete the runtime. If I kill it right now, right, and I refresh, whereas the file that I am uploading to my session will require that I re-upload the file. Accessing a file that is located on Drive only requires that you mount Drive. Okay, observe. I'll scroll down, I'll scroll up here, and then I will import pandas, because I know it's installed by default. After I import pandas, I'm going to attempt to read this local file, which is expected to be part of my session. And I know this will be an error because it's not there. It disappears every time the session or the runtime dies, right? So rather than go through the cumbersome process of re-uploading datasets every time you want to access Google Colab, your best bet is, so this would be an error, your best bet is you upload that file on Drive, and then when you're using Colab, you mount, which I've mounted here, and then I'll come here, and all I'll do is I'll just read the file from Google Drive, and it will work. This won't result in an error. It will work because the file that is in my Drive will always be there unless if I delete that file, ideally. Okay, so quite a useful feature. The choice is up to you on how exactly you want to use these datasets. For some people, what makes sense is you're uploading the files in your session like this. I prefer to link them to Drive. Okay. And then of course, I mean, there's a part where you can also you have access to your data explorer here, is it? I'm not really sure if we'll be able to explore the data if I upload it into my session here. Maybe not. Maybe not. Perhaps, I don't know. I guess what you're exploring here, there are usually toy data sets. They're called toy data sets that are available to you, right? These are pulled from Kaggle and all those things, right? So you have access to those things here. All right. Maybe something else I wanted to kind of mention here. Oh, you can switch these things, which is beautiful, yes. So you can move this data explorer to the right-hand side here. So the other thing I wanted to mention is, if you notice, if you go under files, right, there's this folder which is almost always here when you disconnect from your runtime. It turns out that this is just sample data, right? What the people behind Colab do is that every time they make available the operating system for you to use Google Colab, by default, they also make available sample data here, right? So there's these CSV files. So this is a MNIST data set, I guess, the California housing, and I don't know what this is here. I've never used this here. It would be nice to try and see if we can visualize this data here. I've never really used this data set myself. I don't know what this is about here, but if I do a pandas.read JSON, it's a JSON file, I can read this, is it? And I have no idea what this is. I'll probably have to series X. I have no idea what this is. I'm sure there's a description somewhere. There's a README file actually. You know, it's weird here. And then they have direct links taking you to, yeah, I don't know what this is. A copy of Scombe's quartet. I don't know what this is here. Anyways, so I hope this is making sense. You know. Unless if there are questions, we can proceed and move on to the next phase, right? Now that we understand the tools to be used. And my advice to you is, as we are working through these things, your tool of choice should be Google Colab, right? Because Google Colab will always be accessible as long as you have internet access. You always have access to it. On your phone, on your machine at work, you don't have to worry about, oh, I need administrator privileges to install these tools, so I'm running into errors. This will always be there for you. So at the very least, you want to make sure that you actually know exactly how to navigate in Google Colab. Are there any questions about Google Colab? We could have finished this discussion last time, but if you remember, I was preparing for, there was some meeting I was attending, you know. I don't know if any thoughts or questions about Google Colab. Things that are a bit off, difficult to understand, and things of that sort. Okay, if there are no questions, then we're gonna proceed here, right? We've done the part to do with tooling. We know the tools that we need for us to be able to write code, because this course is all about writing code, right? It's programming for data science here. Now that we know the tool stack to use, the next step is to try and gain an appreciation of this. You know, something tells me, and I'm sitting here and I don't know if I'm mixing things up here. I'll just need confirmation, right? Because I think I'm teaching more or less the same things in some courses as well. Did we start looking at this last time, getting started with Python? I am confused.
We didn't.
Hello? Does anyone, can somebody tell us whether did we start looking at getting started with Python?
No, I don't think we did.
Yeah.
We did not. We did not.
All right, so somebody was, I just saw a message here in the chat. Somebody is saying, can you please explain the error with with the pipe symbol here. Well, so we haven't really gotten to the stage where we're looking at how we use things, but I'm going to explain it nonetheless, right? It turns out that when you are using, I'm going to copy this here, copy this to, I'm going to copy this to CSC 6741 here. I'll dump it to playground or something. And then I will then go to the, I'll go to the directory associated with the course itself, right? And then I'll activate the environment, I guess, I don't know. Now, if you notice, right, I'd mentioned that for this particular course, I've installed all of these packages, right? One of them is Pandas. We haven't really started looking at Python Pandas, but it turns out that the way Python Pandas works is, first, I'm going to show you the dataset itself. The dataset I'm working with, the one that is in Playground here, it has a very strange structure, right? If you notice, it's a CSV file, but the separator, the idea behind the CSV file is the records have attributes that will be separated using a character, a special character, right? By default, it's a comma, which is why it's called a comma separated values file. But it doesn't always have to be a comma, because there are instances when that separator, if made into a comma, might cause havoc, is it? If you're dealing with text where people were writing sentences in English, we write with commas. This is how we structure written language, right? So the workaround for that is you'd use special characters that are less likely to be used when people are writing, like characters like a pipe symbol, or characters like a caret or a tilde. You rarely find these things unless if it's some chemistry text or something like that, right? Where somebody is using these characters to present formulas and stuff. But so using these as special characters makes life a lot easier. You're like implicitly providing a way in which your computer programs are going to easily distinguish different fields. Now, it turns out that in Python Pandas, and we'll discuss, we have a whole lecture series tied to Python Pandas, right? In Python Pandas, for you to be able to read a CSV file, what you do is you import Pandas, I read quantitatively here as PD, and then you would use Pandas itself to evoke the read underbar functions. There's a whole list of functions. We're going to discuss these things here. But because the file I want to read is a CSV file, I will use this read underbar CSV, right? Now, if you look at the manual here, the way this thing works is it expects you to, at a bare minimum, you specify the location of the file, the data file that you want to read. Now, this is the CSV file, right? Which is why I'm using read underbar CSV. Now, if I run it like this, and it tells me this thing is not here, so it's not supposed to be like that here. It's supposed to be, if I run this function like this, I'm not supposed to go directly behind here. It's at the same level here. If I run it, right, you notice that I'm getting an error. And if I scroll up to see what this error is here, I'll probably be able to find details that will hint at the fact that, there's a bit of an issue here with the data, right? It's a parsing error, right? And I know why that is the case, right? The reason is because my file, the records are separated with a pipe symbol. So this method called read underbar CSV allows you to specify a parameter, right? That will indicate explicitly what that separator is in your file. In my case, it's a pipe symbol, right? So if I run this, it will work, ideally. But we'll discuss this later on. Okay. Now, if there are no questions related to this, we're going to jump in straight to this language we call Python. If you remember, I think we had a I'm going to go back here. We had a discussion here about, yeah, we had a discussion about the fact that Python is an interpreted language and all those things, right? And stuff. So we provided context here. Now, I wanted to kind of launch the discussion centered around this part of the lecture series by using this Easter egg. There's an Easter egg in Python, right? So if you just go and import this, you have access to what's called the Zen of Python, right? Yeah, look at this as like kind of like the philosophical underpinning behind why Python would be desirable, for instance. So if you go on your interpreter like this and you just say import this, it's an Easter egg, right? Import this, you have access to the Zen of Python, all right? So Python is better than ugly, right? Beautiful is better than ugly, you know? So Python is beautiful. It's an elegant language, really. It's not very verbose, right? It doesn't require you to write a lot of redundant code constructs here, right? Explicit is better and all those things, right? But simply put, I mean, these are just points that hint at the fact that, I mean, they hint at the philosophy tied to Python itself, right? Now, again, we already kind of highlighted some of these things, but I'm going to regurgitate them again, you know, so that we are on the same page, seeing as we've started looking at Python now. It's an interpreted language. What that means is for you to be able to run programs written in Python on your computer, you need to install the interpreter, right? So you need to have this piece of software, right? Python. In my case, I have Python version 3.12.3. And you install it like any other software, right? It's a scripting language. What that means is that you can actually write scripts and run your Python modules as scripts. So for instance, I'm going to go into Playground and attempt to create just a script file, is it? I'll call this CSC6741 sample script .py. Now, I want to just write a simple function here that tells us, you know, I'm graduating in, and then I'll ask this thing to just use input and say enter the current year. And then I'll say plus input, enter the duration of your program or something. Some simple kind of thing here, right? And what I'll do here is I'll cast this, because these need to be integers here. I'll cast this into an integer. I'll also cast this into an integer, right? Like so. So that when I run this file here, if I run Python, and then I say this, it's going to be interactive like this, right? Enter current year, 2026. Duration is 2 years, and then it tells me I'm graduating in 2028 or something. Although it should be like 2029, I guess. Now, the idea behind the script is simple, right? You can create these files that are executable somehow. In fact, you can add them to what's called the cron tab, right? So that they run on regular intervals. The idea behind the script is these are very small software instructions, you know, that perform specialized tasks ideally. And these are mostly used by systems administrators, for instance, right? You know, you write a script that regularly checks how much disk space is remaining, and if you get to 95%, you want it to send you an email or an SMS so that you're proactive or something like that. Now, I can do this, right? I can change this. It's not a problem. I just say, where is Python or something? So I can, Python 3, I guess is what I'm looking for. So what I can do is, okay, that's fine. Which Python? I guess I can use this anyway. What I can do is this file that I've just created here. I can kind of automate things here and just add what's called a shebang or something, right? Put it here so that when I do this, I can then make this thing executable, right? This file executable, so that I don't have to run it with the interpreter. Like I explicitly say Python space. All I can do is I can execute, and the way I execute files on Ubuntu is ./ followed by the name, right? Like in this particular case, and it runs like that. So I'd have created a script, and with this, really, if it's able to run like this, I've made it executable now. If it's able to run like this, then I can put it onto my cron tab, right? I will be able to run periodically. So it's a scripting language. It's general purpose. You can use it for a whole host of things here, right? Web development. You know, there are platforms, web frameworks like Django, for instance, that you can use for web development. You can use it to write GUI-based applications. I remember when I was teaching this when I was a graduate student, we were using Tkinter, right? Tkinter, right? It allows you to create graphical user interface applications. Let's see, you can use it in graphics. So I teach a computer graphics course, right? And if I were to get to the folder with the environment for the graphics course, and then I activate this environment, and I list the modules that we're using here. You notice that we're using things like PyOpenGL, right? So PyOpenGL gives you access to the OpenGL, the OpenGL API, right? In essence, it allows you to kind of like write programs that are going to run on GPU, right? Graphic-centric programs, ideally, right? So if I check GLX info and I do a grep, I guess OpenGL or something, version, I'll be able to see the version of the OpenGL API associated with my computer, right? And so what we're doing in this course is we're using Python to write graphics applications. Well, we are studying computer graphics, but in the process we're writing, you know, code fragments that are then sent to the OpenGL API. And the idea behind the OpenGL API is, you know, the way it works, in case you're wondering, is the OpenGL API allows you to gain access to the graphics drivers, which in turn will interact with the actual hardware, right? The actual hardware. So what we're doing is we're using PyOpenGL as a wrapper, because we can't directly interact with OpenGL. We're using a high-level programming language. We can, but it's a lot easier when you use a high-level programming language. And guess what? This is in Python. Right? This is Python. Okay, so it's a general-purpose language, and believe it or not, it's object-oriented. Okay, now initially, once we start doing this, when we're looking at Python, we will just look at writing code like procedure or something. But it turns out that a real power in programming in some instances is to take an object-oriented approach, which really kind of helps you mimic what you see around the world, right? So when you're writing computer programs, in most instances, you'd be automating some aspect of what happens in life. So I'll give you an example of, let's say we are building a student information system. The idea behind object-oriented programming, object orientation, is that you can view the different components of the student information system from the perspective of the objects in the world, right? Like we know that there will be a student object here. There will be a course object. There will be a lecturer project object, right? There will be maybe an accommodation or something like that, object. And the idea behind objects is each object is associated with characteristics, right? A student has a date of birth. A student has a name. A student has a student ID, right? And then tied to this is this notion that, I'll call these attributes, this notion that, in addition to the attributes, there are operations that a student object will be able to do, right? Like for instance, you will enroll, right, into a course, enroll in course, or something like that. It's a function. Like you will need to pay fees or something like that, right? And so it turns out that when you're programming, actually, it's a lot easier for you to program when you take an OR approach to code. So we're going to discuss, as we're supposed to discuss aspects of object orientation in this course. So we shall do this, right? Anyways, so quite a number of things associated with Python. In terms of the vision, I am going to be using, if you want to play along with the things that I'm doing here, make sure that you're replicating these things. Probably want to mimic my environment. So I'm using this version of Python. Okay? Version 3.12.3. Although what's important is this major version, really, right? Version 3. Okay. What else? We see here that another interesting characteristic about Python, and you've seen me do this, is you can actually execute these statements direct from the interpreter itself, right? So you've noticed that when I'm trying out code fragments, what I'll do is I'll activate the interpreter by just typing Python. And then when I press enter, I'm dropped into the Python shell, right? If you notice here, it's telling me, you know, you're in this shell here, Python 3.12.3. And then from here, I can run help commands. I can just write help, right? Or help. And then it shows me like different things here, right? I'm just going to quit here. What else can I do here? I can run commands, right? Like print 2026 plus 2 or plus 3, right? I can do a whole range of things. I can perform math functions. Like I want the power 2 raised to the 8 is what? 256, right? So I'm interacting with a shell here, right? So and Python scripts can be executed as shell commands. This is what I showcased to you when I was attempting to run this thing here as a script. I'm running it as a shell command idea. Okay. We already looked at installation and setup, so this is more or less like the replication of what we did before. I should have removed these things, I think, when we were discussing this. Is it? It's a replication of this. Okay. I'll edit this out so that we don't have replicated content idea. Now, there's something interesting if you've programmed before, right? It turns out that crucial to programming, because what you're doing when you're programming is you're telling a computer what to do. And it turns out that when we're using computers, what we are doing actually is we are implicitly asking computers to process data on our behalf. If you are to think about that from the perspective of what is happening right now, I'm asking my computer to process audio, is it sound, coming from my mouth in analog, and I'm asking the computer to say, can you convert this analog into digital form? And then transmit it via the internet so that the people that are logged on to Google Meet right now, to this class, can be able to listen to what I'm saying, right? The instructions here. Now, it turns out whatever you think of here in terms of the computer, you're playing around with data, really. And of course, I mean, there are gory details to do with how is the data processed, your CPU, right? And instructions are executed, they're executed by the processor and all those things here. Anyways, so it turns out, right, data is crucial, but whilst most languages will require that you explicitly specify data types, like for instance, I want to write a program, a simple program, that is going to do it's going to do a simple thing, right? Add 2 numbers. One of the very first things you're going to have to do is, just a minute, excuse me, sir. I do apologize. I had something on the stove and I just realized I'd literally forgotten to switch it off. But one of the very first things you do if you're trying to write a simple program that adds 2 numbers is you've got to, first of all, step 1 is specify first number. Step 2, specify second number, right? And then step 3 would be add first number and second number, right? And maybe step 4, print result. Now, if you're adding numbers, right, one of the crucial things you ideally would need to do in your program is you need to tell the computer to say the type of numbers is this, right? And it turns out that different types of numbers, and we'll talk about that here. It can be an integer, right? 1, 2, 3, 4, right? Or it can be a floating point number, 2.1, right? 2.2 or 2.5. So you specify. If on the other hand, you are doing something different, like you want to process text, a string, you would have to specify the string that you want to process. Now, at the part where you're specifying the number, like in this particular case, specify the first number. What most programming languages like Java will expect you to do is you're specifying the data type. So Java will expect you to say something like int first number is equal to 2. And also int second number is equal to 3. And then at some point you say int result, I'll just call this final result, right? Is equal to first number plus second number, right? Something like this. But with Python, it turns out that you don't have to do all of this, right? All you do is come to my interpreter here. All you do is you say first number is equal to 2. Second number is equal to 3. Result, final result is equal to first number plus second number. And then what you do is you say print final result. That's it. So you notice, right? In all of these different steps I took here, nowhere am I telling Python to say, I want this to be an integer or something. It turns out that Python is able to figure this out internally, right? In fact, if I use the built-in command type and check the type of first number, it will tell me this is an integer. Okay? If I check the type of second number, it will tell me this is an integer. If I check the type of final result, it will tell me this is an integer. If I was to define another number here, total cost or rent cost, or Lusaka BNNB, Lusaka basic needs and nutrition basket is equal to 11,550 kwacha 57 ingwe or something. If I check the type here, you notice that this is a floating point number, is it? Right? It's a float. So the quote unquote data types are inferred. Okay? Hopefully this is kind of like making sense, and we'll talk about data types. We'll talk about data types, by the way. Don't worry. It will hopefully make sense here. The other thing that you want to appreciate is, structure is extremely important in a programming language. It's how it helps with how the compiler and the interpreter is going to be parsing the language itself. Because remember, as the name suggests, what the interpreter or the compiler does is it's converting these instructions you've written in a high-level language like this into a form that a computer is going to understand, ones and zeros. And so for it to convert this to the equivalent ones and zeros, there has got to be some sort of structure, right? In languages like Java and Python and C++ or something, structure is usually specified by braces, and statements are delimited by semicolons or something like that. In Python, it's indentations. And you notice that when we start looking at code constructs like loops, code constructs like functions, and even classes, indentations will become important. So you indent, you explicitly state structure by indenting code. For instance, and we'll discuss functions, but I just want to highlight this as an example. If I wanted to convert this idea of, you remember I wrote a program here that just adds two numbers, 2 and 3. But just like, oh, wait a minute, these numbers here, 2 and 3, the program here is too rigid, right? It can only add 2 and 3. What if I want to add 10 and 500 or something like that? I was like, well, I want to write a function, right? And we'll talk about how functions are created, but you create the definition of the function by using the def keyword, and then you specify the name of the function. So I'll just call this add, right? Then I'll specify that it takes in a variable, number 1, variable, number 2, right? And the way you specify indentation is the full colon is extremely important. Say, I want what comes afterwards to be in the function body here. And then I'll just say var result is equal to var, I'll call this var final. Result is equal to var number 1 plus var number 2. Right? So I've created a function here. And the way this works is I can just call add this and just say I want to add 1 and 2, right? Of course, I made a mistake here. Sorry, indentation, define. Here I would have to say return var final result, like this. So that when I run this function, var add 1 and 2, this thing will say, oh, it's 3. Okay, how about 100 plus 1,000 or something like that? Okay, it's 1,100 or something like that, right? So the key thing here is you notice that I'm indenting here, I'm defining the structure by indenting. And you see a lot of this, right? When we get to conditional statements, like if statements, for instance, we say var final score. Or in fact, we can use the same, var score is equal to 70. And you can have a code construct that says if var score is less than 50, then what is this? Print fail. Else, or if var score greater than 50, print pass. So what this thing is going to do is going to print pass, is it? Right? Because 70 is greater than 50. But you notice the point I wanted to put across is that I'm indenting the things that are supposed to be encased within this if statement. I'm indenting the things that have got to be encased within this else statement. Okay? Again, we're going to discuss conditional statements at length. This is meant to be like one of those gentle introductions to this, I guess. So it will make sense soon enough. So indentation is important. Now, the very first thing, right, that we have got to kind of like discuss at length here before we start getting to loops and conditional statements and stuff is this notion of identifiers, because it turns out that when you're writing a computer program, when you're preparing instructions that are going to tell the computer what to do, that's the essence of the program, there are certain things that are going to be user-defined or defined by the programmer, you, okay? And it turns out, right, that there are rules that govern how you create these things. They're called identifiers, right? So these things could be things that will hold values. Like I want to write a program that's going to tell me if a person has passed the 6741 course. Okay, what is the program going to do? Well, the program is going to have to check if a number provided is less than 50 or if it's greater than 50. If it is less than 50, it's a fail. If it's greater than 50, it's a pass. Now, the number itself, right, has got to be held somewhere, right? A variable. And a variable, it turns out, is an identifier, right? What else? Well, I'm writing this complex program that adds numbers. I can add numbers on the interpreter, right? 1 and 2 and stuff. Like I can come here and I just say print 2 plus 9, sorry, 2 plus 9. I can do, 100 plus 9. I can do negative 100 plus negative 200. It works quite fine. It's negative 300. But what I want to do is I want to write a function, right? A function that adds numbers so that when I call it, when I evoke this function, it's called. So when I call it, I just specify numbers. I want to add negative 100 and negative 200. It gives me the answer. Now you notice here that when I'm defining this function, right, I specify this vxn underbar add. This is, again, it's an identifier. It's a function name, but this is an identifier. Now it turns out that there are rules, okay, in Python that stipulate valid identifier names, ideally. Simple rules, really, right? What's important is that you follow these rules. If you don't follow these rules, you will run into errors, ideally, right? So an error will pop up or something like that. All right. So the first thing to appreciate is that Python is case sensitive. Okay. So things or identifiers with different casing, even if the term is the same, would be considered different by Python. Observe, right? I'm giving an example of age with all lowercase letters, all lowercase age and all uppercase age are different. So if I say, what is your age here? Lowercase age is, my age is 20. What is your age? Uppercase. My age is 30. If I attempt to print lowercase age, I will get what? 20. If I print uppercase age, I'll get what? 30. These are two completely different things. So casing is extremely important. It's one thing. And if you look at casing here, right? The different ways of using casing is all lowercase, all uppercase, title casing, camel casing, right? Whole range of things here. What's important is you appreciate that casing is important. So Python is case sensitive. That's one thing. And there, in terms of specific rules here, there are simple rules. Unfortunately, you have to commit some of these things to memory, I guess. But as you are programming more and more, you begin to notice that it's not really going to be a bit of an issue here. It's not going to be an issue here. So a few rules to kind of like appreciate here. First, you can only use a combination of letters, numbers, or underscores, right? When you're creating variable names. Okay, and I'll give you an example here. What we are saying here, well, let's go through all the rules anyways, and then we'll look at examples here. So you can use a combination of letters, numbers, and an underscore. You cannot use any other punctuation other than the underscore when you're creating these identifiers or variable names. You cannot use Python keywords. So the Python language itself, it's a specification, is it? And it turns out that the language itself is made up of reserved words. They're called keywords. In other words, you're not allowed or you're not permitted to use these when you're creating your variables. Okay? Now, these are simple rules, right? But if you look at these rules here, it's like, think about it from the perspective of you creating an identifier or a variable that's going to hold a score, right? I want a number that's going to hold a score. The very first thing that you're going to have to do is a variable to hold CSC 6741 score, right? Ranging from 0 to 100. If we start using these rules, right, they're telling us something important here. You can't use any other punctuation. So I can't say, I'm going to create a variable, it's going to be called var hyphen score is equal to, let's say the score is maybe an 80% or something. If I enter here, I get an error. You notice this? Syntax error. So I've done something that goes against the rules and regulations of the language itself. What else? If you look at this here, simple rules here, but when you combine them, it turns out that they become quite powerful here, right? Can I use the same variable here? Instead of hyphen, can I put an underscore? The answer is yes. Why? Because they're telling us that when you're creating variable names, you can use letters, numbers, or underscores. Can I create a variable that has 5 underscores or 10 of them? Yes, you can, right? Because it fits a specification that says a variable can have letters, numbers, and an underscore. Can I put a number here? var 1, 2, 3, 4, 5. Yes, this will work. However, if you look at some of these other rules here, right? A variable name cannot start with a number. What does this say? Well, if I want to create a variable and I decide to name it one variable is equal to 55, this will fail. It's a syntax error. Why? Because variables cannot start with a number. They can have all of these. A number can be there in the variable name, but you mustn't start a variable with a number. However, what you can do is you can start a variable with an underscore, right? So I can have underscore variable like that. It will work. In fact, when you print, underscore variable like so, it works just fine, right? What else? A variable can have a number, so you can't say I'm creating a variable called 2006, and then I'm going to assign this a value of hello. This will fail, right? Why? Well, we are starting with a number, but guess what? You can say underscore 2026. This will work. Why? The only restriction is you can use numbers, but the only restriction is the variable name must not start with a number. So meaning that it can start with an underscore. It can start with either of the 26 letters of the alphabet, the English alphabet, but nothing else. Okay? Hopefully the rules, especially the first 3 here, are making sense. We see here that the other thing about variable names is they cannot use reserved words or keywords. So there are these special words, right? And I'll be the first one to tell you that one of the special words is this special word I was using to create a function, DEF, right? If you remember here, DEF here. It's short form for definition. DEF is a reserved word. So I can't say, I'm going to create a variable called DEF and I'll give it the value of 78. This will fail, right? It's failing because DEF is a reserved word. I cannot say I'm going to create a variable called if and I'll call it true. This will fail because if is a reserved word. Now, you're probably sitting there and you're saying, oh, but wait a minute here. How do I know what a reserved word is, what a keyword is? And the answer is the manual, right? So the Python manual will have a list of these reserved words. Incidentally, what you can do is you can do an import keyword, right? And then within keyword, what you can do is you can gain access to a keyword list, and this will list all the reserved words. How many are there in the current version? There are a total of 35, so it's not a lot really, right? And you guessed it right, you're seeing some common names that we've used, right? Remember when we said when you're installing libraries, you use the import statement from import or blah and stuff. Or maybe we haven't done that. No, we haven't done that, sorry. But hopefully you can see some of these things here, right? That are keywords. Not, or, yield, with. And it turns out that these are special because some of them are used to construct certain code constructs, right? Like DEF, where is it? DEF is here. You've seen me use elif, right? When you are including a condition statement, it's if, else, or if, elif. So all of these things, if, elif, and else, these are special words, right? Else, I can't say else is equal to true. This will fail. It's a syntax error. Anyways, I wanted to say something here. One of the things that I personally do, when I'm creating these variables is, I think you've probably already started seeing this, right? This is just me, right? I have my own convention. This is how I write programs myself. But it turns out to be helpful, right? So when I'm creating these variables, whether I'm creating a function, or a variable function name, right, or variable name. For variables, I will always prefix them with var. And then for functions, I personally will always prefix them with fxn, short form for function. So that even if I want to create a variable var if, I won't have a problem, right? I'll just say var if is equal to true, and this will work, no error here, right? I'm running away from the fact that I could potentially use one of these words here, but because I'm prefixing them with a var underbar or fxn underbar, there won't really be any issue here. I hope this is making sense. I mean, we can't really, some of these keywords, they will pop up as we discuss these other things. I think they'll make sense here. Some of them, we probably won't really even use them. Like I don't see anywhere in the syllabus where we use things like async, asset or await, certainly break, yes. Class, definitely. Continue, yes, in loops. I don't know about DL, probably not, except yes, because we need to look at exception handling, I believe. We're supposed to do that. Finally, yes, Yield, probably not. Lambda, I don't know. Yeah, maybe because we may look at list comprehension, we're supposed to look at that. Yield, I don't know, right? So some of these things, they'll be introduced to us as we progress, right? Anyways, hopefully the issue of the rules is okay, is it? It's not that difficult here. I don't think it's difficult to do this here. I'm trying to see here if there's you know that they are what are called PEPs, right? They're called Python enhancement proposals, ideally. And I want to put this as a reading list, really. You probably want to go and read this. These are short documents, really. So I want to go through PEP 8, all right? It's called the Style Guide for Python Code. So really what these people have done is they've come up with a guide on how to name things in Python. These are just guidelines, really, but it turns out that they're quite helpful. I do encourage you to find time and read this, right? I don't know if it's going to be helpful to help you understand this notion of variables. I think it should, you know. I remember reading this extensively myself, but it's not a lot to read, really. It's a very short document. It may help, actually. And it turns out that these style guides are everywhere. Most programming languages will have access to this. Okay, so reading list is prepaid. And you will find PIP 8 available here. I don't know if there are any questions, but I'm going to, as people are thinking about questions, I'm going to start off by reading what's in the chat here. Nanaik has a problem. Could you explain what error? I've already done this. Can you practice this in Jupyter Notebook or Colab? Yes, you can. You can. So most of these things that I'm writing here, these work in Colab. In fact, it's just that I'm much faster when I'm showcasing things here. Like examples, say this variable is wrong or something like that. It's quicker for me to do it right within the interpreter itself, is it, on the terminal, rather than going to Google Colab and saying, well, this is not working, this is working or something. I don't know if that is making sense here. Yeah, I don't know if there are any other questions here. What's the difference between a variable and a function? Well, a variable is just a way of, it's a thing that holds data, right, in a program, and a function itself has a name, right? The name is a variable, right? So you can view a variable here as a way of storing data, right? So a function has a name which is associated with a variable ideally, if that makes sense. Yeah, you probably want to, as we are leaving this discussion of identifiers here, you probably want to practice a few by creating your own variables at your own time and trying to see if these things work, if they don't work, and stuff like that. Are there any specific questions about identifiers, variable names? Okay. It appears there are no questions, I guess. Okay, so we're going to proceed here. Now, what you'd have noticed, right, is that this identifier or variable itself, ideally it's supposed to hold something, right? I just said I created a variable that's going to hold the score. I've named it var score, right? Variables have got to hold something, right? They hold a value. And a value is associated with the data types that you want your program to manipulate. So maybe I'm creating a program that's going to be processing results for students, right? So I'll be working with floating-point numbers or something. Now it turns out that ideally, right, when you're defining a variable, you've got to specify what it's going to hold ideally. You can be explicitly or it can be implicitly, right? And what you do is you use the assignment operator to specify the value held by that variable when you're defining variables. I guess with functional names, it's slightly different, right? So when I create a function using the def, keyword, what's going to happen is this thing here, right? Is if I look at the type here, this variable that I've created implicitly here is going to have a type of, it's a type of function, right? So you don't, I guess you're implicitly specifying the value to be associated with the body of the function or something like that, right? But when you're looking at classic variable names that are going to hold values here, it turns out that what you must do is you specify the value by using the assignment operator, which is the equal sign. Okay, so the assignment operator is the equal sign in Python. So what are we saying? Well, we are saying here then that if I wanted to write a program and part of what I'm doing is I'm specifying the course code and course description at UNZA, I'll just say I'm creating a variable called 6741 underscore code, and then I'm going to assign this the code CSC 6741. See the double quotes, by the way, here is saying it's a string here, but this assignment operator is what is important, right? It's telling me to say this value here, store it in this variable, and then I'll probably refer to it later on. Okay? And in fact, if I check the type here, you'll notice that this is a string, right? str. I can also say, create another variable called description, and this thing is going to be, I want it to hold the description of the course. So I use the equal sign, the assignment operator, and just say this is programming for data science. Right? So the key thing here is that the assignment operator or the equal sign is the one that is used to specify what value is going to be stored in the variable. And you'll soon see, once we start looking at extensively at the different types of data types here, that variables can actually hold complex data types, very complex data types actually, like a list or a dictionary or a tuple or a set, right? A variable can actually hold a complex data type like encapsulation of data, right? Observe. I am going to create a data type. I'll import this Pandas as PD. I'm going to create a data type called var UNZA repository. And what I'm going to do with the UNZA repository is I want this variable to hold all of these, the data that is in here. I want this to hold, this is in playground. I want this variable to hold, maybe I'm already in playground here, I don't know. I hope so. I don't think so though. Yeah, I'm already in playground. I want this to hold, get rid of the error here. This. Now, what I've done here is I've assigned, you see, this file here. It has a lot of data, right? How many records? 1,833 records, right? These. All of these are being held where? In here. In the Pandas data frame. They're in here. Right? And I'm saying this really just to signal the fact that this idea of a data, the idea of a variable, actually, you want to keep an open mind, because the values that you are holding in this variable are not just primitive types, right? They can be different things. It can be a result of a function, right? So for instance, I'll say I have a function that adds numbers here, right? Is it this? It returns a value, right? So when I add 5 and 6, it returns something, a value, it's 11. Well, maybe I want to process that result, right? So maybe I'll write a program and in somewhere I'll have something like result, add result is equal to fxn add 5, 6. So that at a later stage, I can then again dynamically process this, right? Maybe I'll just check if it's odd, if it's odd or even, is it? because this thing here now is now holding 11. So maybe I'll define another function that's going to check is the result, right? When you have a value, var value or var number, I want you to check if var number. Okay, I'll talk about this later on. If I divide this by 2 and it's equal to 0, right? Then I want you to tell me to say this is what? This is even, right? Else, this is going to be odd. So what I could do here is I say, well, I want to see here, given two numbers and you add them, can you write a program or can you write logic that tells you if the answer is odd or even? And it's like, well, I can write a function first that's going to add two numbers. I'll specify two numbers, 5 and 6 or 6 and 7, right? Add, right? This is the answer, it's 13. We know 13 is odd. And then what I can do here is I can say var result is equal to this. And then I'll then run this new function that I've created called, I've called it fxn actually, which is really weird here. And then I'll run this. And then it's telling me the result of adding 6 and 7 is odd, actually, which is 13. If that is making sense. Okay, so what is crucial here is the issue of the assignment operator, right? It's pretty straightforward, I guess. And again, I just have a slide that kind of speaks to, you know, the way that you check for, the way that you check for, I want to call these special, I mean, reserved words, right, or keywords. So you import keyword and then you access keyword.kw list, right? So keyword.kw list. And you notice here, by the way, at a later stage when you look at functions, you can actually check if a keyword, if it's a keyword, is it? There's a function in this package called keyword. There's .is keyword. I can give it a number. Is the word is keyword? Oh, is it? No, come on, is it? If true. How about unza? False. Yeah. So you notice there's also a function in here that you can invoke, right? The is keyword function. And each text that you give it, it tells you whether it's a keyword or not. Is Zambia a keyword? No. Okay. How about DEF? Yes, true. How about else? True. How about elif? True. I don't know about that, but how about while? True. How about for? True. Right? So you have that as well. I don't know if there's anything else of interest in this package. Is of the keyword. I don't know what these things are here. Is of the keyword, right? Is soft keyword. What is that? Soft keyword? Wow. I've never seen some of these things here. But that's okay. It's soft keyword. I don't know. How about I don't know really. Soft keyword, none. False. Okay. That will be interesting. I've never heard of soft keywords in Python. Okay, it's a thing here. Okay, within a specific context, I see. Yeah. Okay, so type, for instance, right? It's not, I don't think type is equal to true. It works here, but it's a soft keyword. So type, wow. Okay, it is a soft keyword. Okay. But they don't result in syntax errors anyway, clearly. You can see that. Beautiful stuff here. Never would have thought. Okay, so there's that. I don't know if there are any questions about identifiers. At this stage, we should be able to do something that's very simple, right? You maybe define, at your own time, you define two variables, you know, var name, right? Then you give this your name, and then you say print my name is full colon. It tells you that or something like that. I'm essentially referring to this variable I've just prepared here, var name. which is being assigned LP. At a later stage, we'll start looking at how you create a dynamic program, right? You'd say, I want you to create a variable name, but this variable name here is going to be dynamically specified, is it? And I'll ask somebody to say enter name, something like that, right? So that, in fact, I want to create this dynamic variable var name. May not be implied here, I guess. Yeah, enter name, right? Right? var enter name. Okay, okay, let's do it. var enter name. Okay, what is your name? LP. And then you have some function similar to that, right? Print my name is LP. I can change this, right? Enter name Zulu or something. Okay, if I print the same thing here, it will say my name is Zulu. Right, so we'll look at, and this is really, it's kind of like an important part of programming, right? You've seen this many a times, is it? When you're logging into, I do encourage you to start thinking wide here. You start thinking about what typically happens when you're using software, right? When you're logging into to Facebook, for instance, this email or mobile number is a variable. Password is a variable. So behind the scenes here, there's like a program, right? There's a program that has been written that captures this and it puts it in a variable. And really, the logic is quite simple here, right? It's like there's the way they've written this, there's a variable called var email or var username, which is, for Facebook, username is email or number, right? And then there's also another variable var password. So when you're here, when you type in your email and your password, what is actually happening is these variables are going to be assigned. My username here will be maybe lighton.piri@gmail.com or something like that. And then the password, usually this is encrypted or something, right? But let's say it's gibberish or something like that. And what's happening in the logic is they've written a program where it goes to check in the database, because most of these things will be stored in a database, right? So there's a database of a database table with a username and corresponding passwords. These are encrypted usually, right? And it's a simple way of doing this here. And so what the program does is it says, get the username specified by the user, get the password, and then check. Is there a record? Select star from users where username is equal to var username and password is equal to var password. This is what happened behind the scenes, really. So you're seeing variables being used on the fly, right? And most your typical applications actually interactive like this, right? Because usually these applications will be used by different types of people, right? That will typically have different profiles on the computer software itself. Anyhow, that's neither here nor there. If there are no questions about variables, we're going to transition and talk about something important when you're writing programs. And those are comments. And really, I want to start off by providing a bit of context here, right? The fact that when you're writing a computer program, it's not going to be 2 lines or 10 lines, right? When you're writing a computer program, I want to start off here by showcasing how complex these modules that I've downloaded are, right? Remember, I've installed is it Python Pandas and stuff. So if I go in lib here, I'll find them here somewhere. These side packages. What I'm looking for, Pandas. If I go in here and I go to core maybe, and I just want to write maybe algorithms or something. Observe this, just this module file here called algorithms, right? There are a number of files here. So the Python Pandas, the Pandas library itself is associated with these module files that have a .py. In fact, there are some files that are in these directories that are in blue here. But if we just look at one, like the algorithms one, have you noticed that this module file itself, it has 1,712 lines, right? If I start scrolling here from the top to the bottom here, there's a lot here. Now, the question to ask yourself is, if this, we don't know when this was written, typically we'll include the date here when this was written. But if we check the repository, we'll be able to check this. But the key thing here is, this is complex piece of code, right, or module file. And if it's complex like this, the question you should ask yourself is, if let's say the person who wrote this died or something, or is no longer interested in responding to queries about this, how easy would it be for people to continue from here? Now, people work in parts when you're programming these module files, right? By the way, I don't know if, I'm not really sure if the GitHub repository has pandas. I think that there should be pandas. Yeah, there's a GitHub repository for pandas. And by people here, I mean this, right? If you notice, contributors, this Python pandas library that we're going to be using, there are 3,682, we can safely say, different types of developers that have contributed source code, right, to this Python pandas library that we're going to be using, right? There's quite a number of them here. Now you see, guys, colleagues, I can't see people that look like us here. It's like, what happened here? Why are Africans never here? I don't know. Maybe they can be there. But okay, that's okay also. Maybe this person is an African here, but I don't know here. But you know, it's a serious question. I'm joking here, but that's a serious issues we need to. There are studies that have been done, right? That seem to suggest that code commits coming in from places like Africa here are nowhere close like these other parts of the world, right? We don't know. But the thing here is that you have this complex piece of code. It's like 1,712. In fact, if I were to give this to you, right, how easy would it be for you to understand this code here? That's a question you should be asking yourself, right? How easy or how difficult would it be? In fact, if I was to write a program, right? So I'm going to write the program to replace the current UNZA student information system. That's a huge code base, right? And I give you the code. How easy would it be for you to understand this? Now, you know, it turns out that the easiest way of doing this is you document, right? You're documenting. So think about this code here, this piece of code as being like maybe a textbook that you would be reading or something. You typically be highlighting and you're writing comments, annotations, right? That's the reason why you need comments, right? Comments will provide you with a mechanism to essentially explain certain portions of code, right? There's something interesting about comments. Because they are explaining portions of code, they are ignored by the interpreter. Remember we said the interpreter actually processes these instructions line by line. So in other words, when the interpreter is scanning through the program, like at some point the interpreter will scan through these 1,700 lines of code when this module file is being executed. Comments will be ignored by the interpreter. They're not going to be converted to ones and zeros. So a question then to ask is, well, but wait a minute, if comments are going to be ignored, then how exactly do we specify comments, right? Turns out there are two main ways of specifying comments. In fact, there are two types of comments, right? There are single line comments and I'll just say multi-line comments. So comments that just span one line, right? And really, you can, the nice thing about this is, let's say I'm writing this function. I'm going to write it again here. I'm writing a function to add two numbers, right? Add numbers then it takes in a variable, number 1, another variable, number 2, right? And then I want this to have a variable, final result. Final result is going to be var1 plus var2 here. And I'm going to return var final result. We'll explain these things later on. Now, if I give this to you, right? It's like, for you to be able to understand what's going on, I need it to comment, right? So I can use multi-line comments or single-line comments. With single-line comments, I would be explaining something like this. Is I would specify a comment here. A single-line comment is typically specified by a pound or a hash like this. And I'll say the final answer returned. Single line here, add the 2 input numbers like this. In all these different instances, what we are saying is that this thing here, right? If I wrap it in a module file, the interpreter, not if, I'm going to wrap it anyway. I'll say sample file. No, sample function. When I run this, right? Remember I was saying this line will be executed by the interpreter, followed by doing it line by line, being translated. When it comes here, it will execute everything here, right? When it comes to line number 2, it will start executing this, and then when it sees this pound, this hash, it will ignore everything after the hash because it's a comment. It will come here. It will start executing this. And then when it sees the hash, it will ignore everything, so it will execute this. That's the essence of a comment, right? So single line comment. It turns out that there are instances where you may want to have a comment that spans multiple lines. Like for instance, right? You want to explain these 2 numbers here. Maybe just having a single line here will not work. So what do? I mean, I know what you're saying. Oh, we can add multiple hashes like this, which works really. You know, this is blah, 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 and then you do this. This will work, right? Because all of these things here after the hash, these are ignored here. But it turns out that there's a more elegant way of doing this, right? You can use what are called Docstring comments, right? So besides the hash, what you do is you use triple quotes or triple single quotes, like so, right? It allows you to specify multiple comments. And these are called docstrings because they're usually used for documentation. So how do we do this? Well, so in this particular case, maybe I want to add docstring, right? 3, like this. 3, triple quotes, like this. And then everything that is wrapped, this is a docstring comment that will span multiple lines. Everything within the docstring triple quotes shall be ignored by the interpreter. Right, so in other words, if I run this here, if I put this in a module file, I come to my module file here, I can probably just delete everything here, I guess, and just replace it with this. When this is being run here, everything, what is ignored, this will be executed, this line here. When the interpreter comes here to find these triple quotes, and it knows what to expect, it will check for the closing triple quotes and it will ignore everything here. This will be executed until here. Everything after the hash is ignored. This will be executed. Everything after here will be ignored. Comments. The interesting thing about these docstrings is I want to show you something here. If I'm to run this on the interpreter, right? Python, no, I'll come here, exit. Ooh, yeah, it's here. I'll do come back here. I'll do Python, and then I run this function, right? Observe this. I'm adding two numbers, right? I'm adding 2 and 3. But guess what? If I do a help and I say add numbers, sorry, if I do a help and I say add numbers like this, it's if you look at this text here, these are the things I was writing, is it? This is a docstring comment that will span multiple, blah, blah, blah. The reason why this is called a docstring is that you use it to provide documentation so that when people are using your programs, they can do this. And you've seen me do this, right? I say import pandas, right, as PD. If I do help pandas, what I'm doing is the things I'm reading, these are docstrings, or created using docstrings, all of these things. Okay. Are you seeing this? Yeah, all of these things here. These are all docstrings. And it turns out, right, I think there should be a Python enhancement proposal. So if you look at PEP docstrings, there should be a Python enhancement proposal. There we go. So it's PEP 257 that kind of outlines the convention for creating these docstrings. These are just recommendations. It's not like your program will fail here. It's always nice to read these things here and understand that. So another reading list is I'll kindly ask you to read PEP 257 docstring conventions so that we understand what this is all about, I guess. Reading this PEP 257 URL is there. All right. These are odd things. If you notice, this was created in 2001. Yeah? If you look at the Python enhancement proposals here, and there are a lot of these proposals. Usually, if you see yourself in this space over a prolonged period of time, it's important that you hone these things, right? You understand these important, investment proposals ideally, and these are generally short documents. If you look at this, it's probably like 2 pages or something, but important nonetheless. Right? It tells you how to write these things here, right? Tells you. I don't know if there are any questions about comments. No, pause here and see if there are questions about comments. We'll probably start spending quite a bit of time when we start looking at data structures, for instance, things like classes and how to create functions and all these things. We haven't yet gotten there. Do we get an error if we don't put a slash? Which slash is this? I don't think, John, I don't think I understand the slash you're referring to.
I mean the underscore.
Oh, no, you don't get an error. That's by choice. You choose. You don't get an error. So here I can say var name. And this is another naming convention, right? If you look at PEP 8, I don't know if you've, probably haven't here, but if you take time and look at PEP 8, right? What PEP 8 does is they're providing you with guidelines on how to name variables, is it? There's indentation, there's variable names, right? Names of variables should nominally use cap words, preferring short names. Yeah. It is recommended to add suffixes, right? There we go. To the variables used to declare covariant or contravariant behavior, right? And stuff. Wow. Global variable name. So they will tell you use function. There's usually mention of how to name variables or something like that. So no, you can choose. And in fact, some people would say, using my same approach here, remember I said I use var underscore. This is just me, right? What you can do is you can say, well, I'm just going to use a var, but then I'll say var name, uppercase N, right? To tell somebody, to say, when you see an uppercase here, it's like I'm transitioning to a different word, if that is making sense. Yeah. I don't know if there are any thoughts or questions about comments, but Yeah. I'm going to suggest that we pause here. I let you, we've unpacked quite a number of things here. I want to leave you with this. I think for now, seeing this is a continuation of that, for now, I think it should be enough to keep you busy, to read up. We've done quite a bit here, comments, variables, and assignment, right? How you assign values to variables and stuff. This should probably keep you busy here. I don't want us to transition into data types. We shall start data types when we meet next. I want to suggest something else. Please let me know. You must let me know. I don't think you have class on Friday. Thursday, though, is a holiday. I don't know. If you don't have, we can have a session on Thursday, because I want to give you time here to kind of breathe here. Tomorrow is a holiday, we don't have class, but I would like to, if you want to have class here on Thursday, let me know. If not, we can do Friday. I want to suggest we do Friday. You know, so we can do Friday, Friday evening, you know, session, and then we do another session on it's a makeup, by the way, but we do another session maybe on the Sunday or Saturday, right? This coming Saturday or Sunday, you know. So let me know, you know. I think for now we can leave it at that and let you guys think about these things, you know, so that when we meet next, we transition into data types, start looking at functions, data structures, looping constructs, the whole 9 yard here, right? And stuff. And I think I need to expand upon this here. I need to expand upon this here because we're supposed to, okay, it's supposed to be part 2 here anyway, not, we're supposed to have a detailed discussion of these things here. I don't know, maybe it should be a separate lecture series or something for these data structures, list tuples, dictionary sets, you know, list comprehensions and all those things. All right. If there are no questions, thank you very much. I shall share the recording, I believe. But what I also wish to do right now is I would like to already give you access to, where is that thing here? I want to already give you access to this thing that I was using as an example. I was making a mistake. It's not really a mistake, but I always 741. I always don't, what's this? Maybe I should prepare a notebook actually. I'll prepare a notebook for this, but in case you want to refer to some of these examples, the problem is I normally use the terminal for this, but nonetheless, I'm going to share this notebook that I was using for live examples or something like that. And I'll make this accessible to anybody with a link here. Hopefully it should be helpful. Yes, there's a hand up. Please, Ms. Sarah.
Just a reminder on
A reminder on
the notes, the lecture notes.
Oh, yes. I shall share them. Apologies that I didn't. I shall share them with you guys, and yeah, I shall share them. Just give me, I think today actually, right? Just a few minutes from now, I shall share them. The recording, in case you need it, though, is going to take a while because I typically would have to process it and then dump it on YouTube or something. All right. Yes, David has a hand raised.
I think I was not qualified on how you resolved that error when you were loading data. Usually, I suppose that that's not the only error that we can experience when loading data. So
no, there are a lot of errors that you experience.
Okay, so how did you identify that you were supposed to use a separator?
Well, I look at the chain. So I look at the errors themselves. The errors give away that. So if you notice, there was some error that came up, right, when I was attempting to read data here. So I look at the error itself, and we will discuss all of these errors. So in essence, I was just saying, import pandas as pd, then I'd say pd.read CSV. You have to read the entire chain, right? The errors themselves, and we'll discuss these errors anyways. So when you do this, right, I'm looking at this. These are errors here. It's a parsing error, if you notice. So I essentially start from the very top here, right? I'm checking. This is the error stack itself. And I'm checking to see what could have caused this. And there's smart ways of doing this, right? The error handling and stuff. So you've got to read all of these things here. Yeah. But this is tied to exception handling, right? Where you can write a program in such a way that it handles all of these things, and you're able to pinpoint exactly what is causing this. So if you notice here, it's pointing you to things that clearly indicate that it's a parsing error, right? Do with the rows or something, right? If you notice, look at this, expecting 2 fields in line 4, so 3, right? Now some things may not really be intuitive like this, which is why you'd have to look at the entire error stack. Yeah, but it's not that hard to figure out what could be causing this. This usually.
All right, thank you.
Yeah, but in case you're one of those people who's, what are we talking about here? We haven't even started looking at Python pandas. You know, we have a dedicated, we're supposed to have a dedicated lecture where we look at the library itself. And so we're going to be looking at who experience these errors, and we look at exactly how we go about solving them, how we identify them. And in fact, by that point, we would have also discussed extensive exception handling. So it will be fine. You understand all of these things. All right. Any other thoughts, colleagues? If not, apologies to the females in our female colleagues here are supposed to be celebrating Women's Day here. Happy Women's Day, by the way, to our female colleagues. You know, enjoy. I think you are celebrating. Tomorrow is a holiday again, thanks to the women here. Otherwise, would be clocking in here, going for work. But also, I think there's a workshop happening, and we have to go and open the lab tomorrow, so I have to go there. But thank you very much, everybody. I will see you when you see me. I'll be waiting to hear from you about the Friday session, please. I'm proposing that we have class on Friday. If not Friday, we can just push it to Saturday or Sunday next week. Thank you. Good night.
Good night. Thank you.